So good day. So this video is about trapezoidal rule. So in problem number 1, a function of f of x is given by the table of values using trapezoidal rule. The area under the curve is y is equal to f of x between the x is equal to -2 and x is equal to 2 with n is equal to 4, subinterval is. So our choices, in A we have 11.5, in B we have 12, C 10, and our letter D is 13. So for our solution, the formula of our trapezoidal rule is equal to the Tn, which is the subinterval, is equal to the width of interval all over 2 times to the function of x sub 0 plus 2 function of x1 plus 2 times function of x2 plus 2 times function of x sub 3 and plus the function of x sub 4. So here's our formula in trapezoidal. So since we don't have the value of the width of interval, so for the width of interval, our formula in width of interval is equal to width of interval is equal to b minus a all over n. So since our b is equal to 2 and our a is equal to -2, and for our subinterval is equal to 4. So 2 minus our a is -2 all over 4. So 2 times 2 is -4 times negative is positive, divide 4 is equal to 1. Our width of interval is equal to 1. To find our trapezoidal rule or the area of the under the curve, so our area is equal to our trapezoidal, which is Tn, or our subinterval is equal to 4. T4 is equal to 1/2, since our width of interval is equal to 1, over 2 times our function number 1 is here. We can see this table with an interval of 1. So our function 1, our function of 0 is equal to -1. So -1 plus 2 times the function of x1, which is 1, plus 2 times the function of 2 is 3, so 2 times 3, plus 2 times the function of 3, which is 5, plus the function of x4, is equal to 7. So our approximate area is equal to T4. So 1/2 times -1 plus 2 times 1 plus 2 times 3 plus 2 times 5 plus 7. So our answer is 12. So our approximate area is equal to 12. So our answer in this problem number 1 is letter B. Next problem in trapezoidal rule. So problem number 2. So find the approximate the integral of 2x plus 8, the limits of 2 and 0. So with the n is equal to 2 subintervals. So in our A we have 40, B 30, C 20, and for D is 50. So for our solution, our formula in trapezoidal is equal to Tn is equal to the width of interval over 2 times the function of x sub 0 plus 2 times function of x1 plus the function of our x2. So for our width of interval, so width of interval is equal to b minus a all over n. Since the value of our a is equal to 0 and b is equal to 2 and our subinterval is equal to 2. So our b is 2 minus our a is 0 all over 2. So 2 divided 2 is equal to 1. So our subinterval for our width of interval is equal to 1. So next is, after we find the width of interval, so we proceed on the values of functions. Values of function. Our function of x sub 0, which is the function of our 0 is equal to 0. So since our equation is 2x plus 8, so 2 times 0 plus 8, so is equal to, so 2 times 0 is 0 plus 8 is equal to 8. Next, our function of our x1, since our width of interval is 1, so 0 plus 1 is equal to 1, so the function is equal to 1. So 2 times 1 plus 8 equal to 2 times 1 is 2 plus 8 is equal to 10. Next, in function 2, so since our interval is 1, so 1 plus 1 is equal to 2, f sub 2, so 2 times 2 plus 8. So 2 times 2 is equal to 4, plus 8 is equal to 12. Since we find the values of functions, let's proceed on the trapezoidal formula. So for our Tn, or for our T2 is equal to width of interval, which is 1 over 2 times the function of our 0, is equal to 8. So 8 plus 2 times function of our x1 is 10 plus the function of x2, which is 12. So for our T2, so 1/2 times 8 plus 2 times 10 plus 12 we have value of 20. So the answer in problem number 2 is 20, which is letter C. So in problem number 3 in trapezoidal rule, so evaluate the integral of dx all over 1 plus x squared with the limits of 3 and 0 using the trapezoidal rule, and estimate the relative percent error of the approximation, and the subinterval is n is equal to 4. So for our solution, so our formula first is in trapezoidal, so Tn is equal to the width of interval all over 2 times the function of x sub 0 plus 2 times the function of x1 plus 2 times function of x sub 2 plus 2 times function of x3 and plus function of our x sub 4. For the width of our interval is equal to delta x is equal to b minus a all over n. Since the value of our b is equal to 3 and our a is equal to 0, and the value of our n is equal to 4. So 3 minus 0 all over 4. So 3 minus 0 over 4 is equal to 3/4. So this is our width of interval. So next is the values of function. So our values of function for our function of x sub 0 is equal to 0. So our equation is dx all over 1 plus x squared. So it's equal to 1 all over 1 plus x squared, which the value of x is equal to 0. So 0 squared. So 1 all over 1 plus 0 squared is also equal to 1. Next, the function of our x sub 1. So since our width of interval is 3/4, so our function of x1 is, so 0 plus 3/4 is also equal to 3/4. So 1 all over 1 plus 3/4 squared. So 1 plus 1 3/4 squared. So we have the value of 16 over 25. So 16 all over 25. Next, in function of our x sub 2, so 3/4 plus 3/4 is equal to 3/2. Wait, check natin. 3/4 yeah, it's equal to 3/2. So 3/2. So 1 all over 1 plus 3/2 squared. So 1 all over 1 plus 3/2 squared is equal to 4 over 13. So 4 over 13. Our function of our x3, so 3/2 plus 3/4 3/2 plus 3/4, we have 9 over 4. So in function x3 is equal to 9 over 4. So 1 all over 1 plus 9 over 4 squared. So 1 plus 9 over 4 squared is equal to 16 over 97. So 16 over 97. Next, for the function of our x4, so 9 over 4 plus 3/2. 3 halves is equal to 3/4 is equal to 3. So function of our x4 is equal to 3. So 1 whole over 1 plus 3 squared. So 1 over 1 plus 3 squared, so is equal to 1 over 10. So for our trapezoidal, is equal to our width of interval is equal to 3/4 over 2 times the function of our x sub 0 is equal to 1 plus 2 times the function of our x1 is 16 over 25 plus 2 times the function of x2, which is 4 over 13, plus 2 times the function of our x3 is 16 over 97, plus the function of x4 is 1 over 10. Three-fourth over 2 3/4 over 2 times 1 plus 2 times 16 over 25 plus 2 times 4 over 13 plus 2 times 16 over 97 plus 1 over 10. So we have the value of 1.24698. So our Tn or our T4 is equal to 1.24698. 1.24698. So we have our solution in trapezoidal. So next we proceed on to find our true solution. So in our true solution, is the limit integration of 30 dx over 1 plus x squared, or equal to arctan of x. So our arctan of R3 minus the lower limit, so arctan of 0 is equal to 3 minus arctan of 0. So we have value of 1.249046. Next is, since in this problem is we need to find the relative percent error. So our relative percent error, or for our relative errors, so the formula of our relative errors is equal to the true value minus the area of our trapezoidal all over the true value. So our relative errors is equal to our true value. We have 1.249046 minus the area of trapezoidal, which is 1.24698. 1.24698 all over the true value of 1.249046. So our percent, or our relative percent error, so 1.249046 minus 1.24698 all over 1.2499046 times 100. So we have the value of 0.165%. So the answer in problem number 3, or the relative percent error, is 0.165%. So the answer is letter C. So next, in trapezoidal rule, engineering problem. So shown in this sketch below are the measured offsets from a traverse line AB to an irregular boundary and the spacing between the offsets. So employing the trapezoidal rule, and determine the area bounded by the traverse line, the irregular boundary, and the end offset. So here's our diagram, or our sketch diagram. So to find our area, for our solution, before that, so our formula to our area is equal to h, or the interval, all over 2 times the y1 plus yn plus 2 times y2 plus y3 plus y4 until y sub n minus 1. So for our y1, so in this diagram, so these are y1, y2, y3, y4, y5, y6, y7, y8, and our y9. So for our y1, we have the value of 5.60 meters. For our y2, we have 6.40 meters. Our y3 is equal to 7.90 meters. Our y4 is equal to 6.20 meters. Our y5, we have 7.50 meters. Our y6 is 9.50 meters. Our y7 is 12.30 meters. Our y8 is 10.80 meters. And for our y9, we have 2.70 meters. So our interval in every boundary is 6. So for the value of our interval is equal to 6. So in this formula is we need to find the value of our y1 plus yn, which is our n is equal to 9. So for our y1 plus y9 is equal to, our y1 is 5.60 meters plus our y9 is 2.40 meters. So 5.60 plus 2.40, we have 5.60 into 2.40, so 9 is also is 270. So 270. So our y1 plus y9 is equal to 8.3 meters. And for our y2 plus y3 plus y4 until yn minus 1, or until our y sub 8, since our n is equal to 9, so minus 1 is 8. So y2 plus y3 until y sub 8. So 6.40 plus 7.90 plus 6.20 plus 7.50 plus 9.50 plus 12.30 plus 10.80. So our y2 plus y3 until y sub 8 is equal to 6.40 plus 7.90 plus 6.20 plus 7.50 plus 9.50 plus 12.30 plus 10.80. So we have value of 60.6. 60.6 meters. So since we have the value of for our formula, so let's distribute the value. So our area, our interval is 6 meters all over 2 times our y1 plus yn or y8 y9 is equal to 8.3. So 8.3 plus 2 times the function of y2 until y8 is 60.6 meters. So 6 squared 6 over 2 times 8.3 plus 2 times 60.6 is equal to 388.5. So the area bounded by the traverse line is 388.5 meter squared. That's all. Thank you.